Hi everyone, welcome to my YouTube channel. I hope you are doing extremely well. First of all, if you are new to this channel or if you haven't subscribed my channel till now, then guys do consider subscribing my channel. It will really motivate me to create more such content for you. Also, you can follow me on other platforms as well. The link is there in the description itself. Right. So as usual, first of all, we'll be starting with the problem statement, then the logic part, and then we'll be having a look on the coding part. One thing that I am repeatedly getting the sort of comments on my videos, that is regarding to do the code in a specific language. So guys, just to mention, your main focus should be understanding the logic part. I mean, the thing that here we are focusing on is developing the problem solving skills, and this is not something magical that will happen. Obviously that will happen by solving the questions, right? So what sort of questions we are solving, slowly this problem solving skill will develop. So our main focus is for that, not about the implementation. See, once you got the logic, you understood that how we have to solve this problem, then obviously in every language we do have, array, we have other data structures, we do have sort of implementation can vary, but yeah, everything is same only, right? So once you got the logic, so you can implement it in your language. I mean, the language you are comfortable with. So yeah, I hope that it makes sense. So let's hop on to the question now. So the question says, given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I, right? So the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in big O of n time and without using the division operation. So we are having an array nums. We have to return an answer that would be an array. The thing is that answer I is equal to, so whatever the ith element that we are calculating for our array, that is named as answer. So for that, this answer I is equal to the product of all the elements of nums except nums of I, means this is our nums array. It is containing the elements 1, 2, 3, 4. So if I want to know that what element to place at this ith index, means at 0th index, so it is nothing but the product of all the elements of nums except nums of I, means, so whatever is the element at nums of I, means as of now we are talking about the 0th index, so we don't have to include this one. Other than this, whatever the elements are there, their product is going to be placed here. So 4, 3, 12, 2, 24, right? Similarly for this index, if you will see, so we have to just leave 2 and other than this, the product of all the remaining elements, right? So 4 3 12, 1 12, so 12 we got here. Similarly for this index, for second index, we have to leave 3 and the product of all the elements, so 4 into 2, 8 into 1, 8 will come here. Likewise, 4 we will leave here, right? So 3 2 1, that 6 will come here, right? I hope that it does make sense. So that is what our problem statement is, and that's what we're supposed to do. One thing they have clearly specified is that they're asking basically us to use an algorithm that runs in big O of n time, and they are not allowed to use the division operator. So here you can have a look on the on the constraint and follow-up part as well. Like if you can solve this problem in big O of one extra space complexity, also mention that the output array, because we have to return the array, right? So the output array will be counted here as, does not count as extra space for space complexity analysis. So now we will think about it, like how we can solve this problem. So although here they have, let's say if this was not mentioned that division operation you cannot use, so probably most of you, or like how we'll be approaching this problem. So let's do in this way. What we can do is that take our array, go through all the elements, and in a variable just store the multiplication of all the elements, right? The complete array multiplication is stored in a specific element, and just every, let's say we came on this one, for example here, if I will do the multiplication, 4 into 12, 4 into 3, 12, 24, 1, so 24 divided by 1, we will get 24. Similarly, the overall product basically that we have got, that we will divide by the ith element of nums array. 24 divided by 2 we'll get 12, 24 divided by 3 we'll get 8, 24 divided by 4 we'll get 6, right? So that's how it would be, right? But again, as they have said that we cannot use division, so obviously we are not going to use that approach. The second thing that you can think of is that what we can do, let's do in this way. We will have a loop. Let's say we are having 1 2 1 2 3 4. So first what we will do, we will have another loop inside, because see, one loop will be responsible to iterate each element and another would be responsible for doing the product and checking that the ith element should not be, whatever the ith element is at the nums, if we are on that particular position, that particular ith position, so that particular element should not be included. For example, so as of now the chosen element is what? Chosen element is 1. So what we have to do is that we have another for loop which is responsible for the multiplication part. So in nums of I, we have to store the product, right? So what we will inside it, we will check that whatever, like let's say you took j, so for int I, int j equal to 0, j less than n, j plus plus, and we will check if I not equal to j, right? I value should not be equal to j, means the index should not be same. So do the multiplication. So 0 1 0 1 is not going to be considered, so 2 into 3 into 4, so that will give us 24. So at nums of answer of I, we will keep 24. Similarly, next after that, next chosen element would be as if we have iterated the complete array, right? So again we'll move on to the outer loop. So next chosen element would be what? 2, right? So again we will move inside the inner loop which is responsible for the multiplication part, right? So we will see this time the index that is concerned, that is what? One index, first index that is concerned, right? So we will do uh, one of first we are starting from 0th index, right? So 1 is going to be included in our product. Now we will check, we are having that check also, right? I not equal to j, so j value is 1 and I value is also 1, so this 2 is not going to be included, right, in our product. So 3 1, then again we will hook on to this one, so this one will be included, this one also included, so we will get 4 into 3 12 into 1 12, so that will be placed here. Likewise 3 is not going to be included, 4 into 2 8 will be placed here. Likewise 4 is not going to be included, and 3 into 2 6 into 1 6 is going to be placed here, right? So similarly likewise for that also. So in this approach we are having 2 loops, right? And yep, in the outer loop also we are moving till big O of n, and in the inner loop also we are moving till big O of n. So what would be the time complexity? N square. N square is the time complexity. So I believe most of you must be able to come up with this approach, right? If not, you don't need to give up, it's fine, right? Understand, watch the complete video, understand all the approaches. After some days, try from your side. Even if then also you are not able to come up, watch the video again, then after some days try the question. I'm just saying this because I have also gone through the same kind of thing, so you don't need to feel like, okay, why I'm not able to think, or just giving up wali cheese, right? So you don't have to do that, right? Because anyhow we have to develop it, and together collaboratively we are doing, okay? So that's what. So here they are saying that we have to write an algorithm that runs in big O of n, and without using the represent that all discussed. So big O of n they are saying. So what can we do to solve this problem? So here what we will do, we will calculate the prefix and suffix product. Okay, ऊपर से गया ना? Let's understand what I actually mean. So let's say here we are having 1 2 3 4, right? So what we will do, we will take 2 arrays. Let's call one array as left, which will store the product. I mean, let's say our concerned index is 3. So we want the product at left of I, means at left 3 is at on what index? 0 1 2. At left of 2, put the product up till that particular index. Given that this number, this, I mean, whatever the element is there on that particular index, that is not going to be included, right? It will make more sense when I'll do the dry run part. Similarly, right, we do have. So in the left case, we will move in this way, in the left direction. In the right, we will start from right direction. So in the left array first, so 1 would be there, right? 1 would be there, because see, before that, before the first element we don't have anything, right? So we will keep 1. Then before this 2, what is the element? 1, right? So we are going to include that in our product, so we will be having 1. Then before this index, what do we have? Before this index, what do we have? 2 2 2 1 j 2, right? So 2 is going to be included, right? Then before this, what do we have? Before this, what do we have? Before 4, like we have to determine What is the product? What is the product of all the elements? So obviously, see, it's not that you have to consider this completely. Up till this, we already have. Up till this, we already have, right? This is stored here too. So what simply you have to do is whatever is the element at the I minus 1 position, 3, multiply it with the element that is at left I minus 1 position. So what is the element at left I minus 1 position? 2. So 3 into 2 will get 6. Now similarly we will do for right. So in case of right also, is there anything before 4? Nothing, right? So here we will have 1. Then we'll move to this particular index. So what do we have? What would be the product of all the elements before that? 4. 4 into 1. We'll be having what? 4. Then we will move to this particular index. So what is the product? So again, same thing. What is the element at nums of I plus 1 position? Nums of I plus 1 position, right? So we have 3. And what is the element? Right. Nums of, and yeah, what is the element at right of I plus 1 position? So 3 into 4. 3 into 4, we'll be having 12. Right? Now likewise we will hop on to this particular index, this particular position. So what is the element? What is the element at this particular position, I plus 1 position? That is 2. 2, right? Nums of I plus 1. And what is the element at right I plus 1 position? 12. 12 into 24. 24 we will keep. Means this complete sum we have got, right? From the right side. So now we have our left and right arrays ready with us. Now, if you just have a look on it. So what simply we are supposed to do? Left array is having what? Left array is having what? We are having 1, 2, 3, 4. So at a particular index, for a particular index if we are talking about, so what is the multiplication from the left hand side up till that index? Given that the product of that particular index has not been included from the left side. Similarly, if talking about the right array, so what is the product of the elements from the right hand side, given that the product of that particular element is not included, right? So that's what we need. So from the left and right, from both the sides we have the product. So in the answer array, what we'll be doing is that, so for example, so what we can do, so left of 1 is having what? Whatever is the product of the elements before this index, right? And right one is having the product of all the elements at the right hand side, from the right hand side, right? This element is not included. This particular index is not included in both the cases. So how you can, so we can directly say, right? We can directly say, so means the answer we can get from the multiplication of left of I into right of I. So that would be 24. Similarly, if talking about this index, so directly you can just check in the left of 1. Left of 1 is basically having what? The product of the elements from its left hand side. Left of 1 is having what? The product of elements from its left hand side. In given that the product of this index was, this index was not included in the product, right? So what is that? 1 we do have. Similarly, from right of 1 you will get the product from the right hand side. That was 12, right? So 12 is given. So this 2 was not included, right? This 2 was not included in both left and right case. So what we will get? 12 into 1, 12, right? Similarly, here we will get 8, and here we will get 6. So 24, 12, 8, 6. So that is what our answer is. So this is the approach that we can follow for solving this particular question, right? So in this approach, what was the thing that we don't, we are having with us left and right array, right? And with them we can just check, okay, this is giving us कि left hand से किसी भी particular element का product क्या है, making sure कि वो वाला जिस भी हम इंडेक्स की बात करें उस इंडेक्स का एलिमेंट को हमने इंक्लूड नहीं किया. एंड राइट वाला हमें क्या बता रहा है? राइट वाला बता रहा है कि राइट हैंड से क्या है. दैट इज ऑल्सो दैट यही तो चाहिए, हमें लेफ्ट से चाहिए और हमें राइट से चाहिए, और मेक श्योर करना है कि वो वाला इंडेक्स उस पर्टिकुलर इंडेक्स का जो एलिमेंट है वो इंक्लूड ना हो, वो एलिमेंट इंक्लूड ना हो, राइट? सो हमें हमारा आंसर मिल गया. सो दैट्स हाउ वी कैलकुलेटेड आवर आंसर array, right? So if talking about this thing. So what would be the time and space complexity for this particular approach? So first, what we are doing is that we are like let's have a look on the code part. So left and right array we have. So this is the extra space we are taking first of all, right? Result array is not considered in the space as if given the question. So but left and right, this is we are using for our own purpose. So zeroth element, zero at zeroth index C. Before that there is no element, right? So we will put at left of 0 as 1, and then we will start iterating. I mean, we are just computing the value for left array. So I equal to 1, I less than n, and then how we are computing left of I, we are computing as that whatever is the element at left of I minus 1 position. So what was the element? 1. Take it, and take the element from nums of I minus I minus 1 position. So 1 into 1 we will get 1. Similarly, when I would be 2, so take the element from left of I minus 1 position means left of 1. So what is that? 1. And nums of I minus 1 position, that is 2. So 2 into 1, you will get 2. So that's what we placed at nums of 2. And similarly, we calculated nums of 3. Right? So we have got 1, 1, 2, 6. Then likewise, we will compute our right array. So again, at n minus 1th position, and n minus 1, because see, before I mean, in the right of the 4 we don't have anything, right? So that's why we will place just 1 only here. So that's what we are doing here, that at right n minus 1th index, just place 1. Then we are having a for loop for int I equal to n minus 2, I greater than equal to 0, I minus minus, and here we are just computing the value for right ith index. And how we are doing it is like see how we were doing that. Take the element. So I have to compute for this particular index. So how I'll be doing that? I will take the element at this, I mean, right ka I plus 1 index pe what is the element? 1. And nums ka I plus 1 index, what is the element? 4. So 4 into 1, 4 we will take, right? So likewise we will compute here. So that's what you can see. I have done right of I equal to right of I plus 1 into nums of I plus 1 position, right? So now our both left and right array has been prepared. So now we will just prepare a result array. So result of I is equal to left of I into right of I, and at the end we will return a result array, right? So that was the, as of now, just don't have a look on this part, this code. So that's how we have calculated. So 3 times we are just iterating. So big of n would be the time complexity, and here, but here we are using the extra space. So can you think, I mean, any approach by which we can make it happen in big of one time complexity? Because that's what we have asked. They have asked that can you solve the problem in big of one extra space complexity? So what we can do is that so as of now, what we are doing is that we are calculating the left. Okay, we are calculating the left, and left array. We are doing the computation of the left array, and we are doing the computation of the right array. So let's compute the left array. But instead of computing the right array, we can simply have just one variable which will keep track of the product from the right hand side. What do I actually mean by this? So let's take a variable. Let's call it as right, initialize with 1, and yep, on the basis. So at the end in the answer array, what we are doing, we are just multiplying answer of I, left I and right I, right? That's what we were doing. So we don't need, we can avoid this extra right array that we are using, and let's see how. So 6 as of now here we have, right? So if when we were talking about when we are saying at the right of 4, what do we have at right of 4? What do we have at right of 4? Nothing, just 1, right? So we will update the value at left ka last position, left ka end position. How we will update it is do right into, because right would be storing what? The element which is there at the right from this last element of the nums array. So just do the multiplication of this right to that of the last element of the left array. So what is that? 6 into 1, we will get 6, right? Now if you will see, so now what is the now we have to take this element under consideration, because we will move ahead now. I value will move ahead. Let me show you this part. So we are starting from n minus 1 position, right? And we are updating the left of I as left of I multiplied by right. And now as if we will move ahead, so that's why we'll make sure now we have to consider, we have to count this element. So 4 into 1, this time we will get 4, right? So for that particular index, if we are talking, so in the left we already have left. So what is the product? 2. And right, so also we do have the product, right, in this right element, in this right variable, sorry. 4 into 2, just multiply 4 into 2, we will get 8. Now let's proceed further. So for this, in also you have to keep on updating the right also. So right, now in right we will include this element also. So 4 into 3, we will get 12, right? Now for this particular index, what do we have? That yep, what do we have? That from the left, what is the product? From the left for this particular index, what is the product? 1. And from the right, what it is? 12. We already computed, right? So 12 into 1, we will get 12. Right? Now we will proceed ahead and also updating the right value by including this nums of I. So 12 into 2, we will get 24, right? So now for this particular index, if we are talking, so what is the element from the left hand side? 1. And from the right, we already computed in our right array. So 24 into 1, we will get 24. So 24, 12, 8, 6. That is what the result been stored in our left array, and that is our expected answer. So at the end, we'll be returning just the left array. So see here, in that case, we just used this output array that we're returning at the end, that is the left array. So the time complexity is big of 1 because that's this one is not getting counted as in the sorry, what I'm saying. So yeah, as if we are just having just one left array, right? That's what we are returning at the end. So what would be the space complexity? Space complexity would be big of 1 because as if they have clearly specified here, the output array does not count as extra space for space complexity analysis. So we have reduced the time complexity is still the same. However, it's still reduced from when compared with the previous cases because here we are doing the 3 iterations, right? Now just one iteration to compute the left and second iteration to update the value in the left array and the right variable that will keep track of the element, the product of the element from the right hand side, right? So we are doing that, and at the end we are just returning left array. That is our actual answer. So this is not needed now in the code result. This is also not needed. Just this left array we're going to return, right? So what all we need to do is that computation of the left array, and at the end right, not array but the variable that we're going to take, initialize with 1, and we will start doing the iteration from the right side. So int I equal to n minus 1, I greater than equal to 0, I minus minus, left of I will be updated as left of I into right, right will be updated as right into nums of I, and at the end we will return the left array, right? So these were the approaches to solve this particular problem. I hope you were able to understand, and if you got the logic, then you are going to solve this by yourself. The implementation you are going to do by yourself in the language that you are comfortable with. Any feedback, right? So just guys, I need the feedback. I mean, there could be a possibility that my way of delivery is not that effective. Matlab, could be. For some of you are able to understand, some of you are not able to understand. If there is any such case or any feedback is there, just let me know in the comment section so that I can improve. Right? So thank you so much for watching, everyone. Bye bye. Maintain the consistency. Bye.